4.4a, fundamental theorem of the entire course. Differential, slope of a tangent line, integral, area. Fundamental theorem made by these two guys. This is Isaac Newton and Gottfried Leibniz. All right, slope of a secant line to slope of a tangent line. And then area under a curve we did with rectangles, remember? And so now we're going to get those rectangles really close to actually find the true area under the curve. All right, I need you to write this down word by word. This is the fundamental theorem of calculus. All right, most people contribute it to call it the first fundamental of calculus because we will get another one. Right? And so this is what it is. If a function is continuous. In layman's terms, what is continuous? You can do what? Draw it without lifting your pencil. Mathematically speaking, what is a definition of continuous? The limit is equal to the value. All right. So if it's continuous, if the function is continuous on the closed interval, and we can find an antiderivative, then the integral from a to b of f of x is equal to big F of b minus big F of a. So I need to record. So this a is your lower limit, your b is your upper limit, all right, or your lower index of summation and your upper index of summation. This f of x is your function. And so what it is you take your antiderivative of f, so it's big F, and then we substitute in our upper, and then minus we substitute in our lower. All right, and so we need to talk about notation here, and I need you to write out this notation, and we'll practice it, but this is the way we write it. So if we have an integral from a to b of our function, the first thing we do is we take an antiderivative of it, because that is what an integral is. All right, so we say it's equal to our antiderivative, and then we have this little bracket going on. This is the only notation I've ever seen happen. All right, so we have this bracket going on, or sometimes people put a line, but those are the only two that's basically there. And then it goes from my lower to my upper. Now, a lot of the times I will put a parenthesis right there as well, because sometimes we work with constant multiples, and I'll put that outside of it. But that's the notation. And then the way we work with it is we substitute in our upper limit into our antiderivative, and we subtract when we substitute in our lower limit. Okay? So you can look at this next one, or you can just kind of play along. So if we have the integral from 1 to 3 of x cubed, well, what is my antiderivative of x cubed? My antiderivative of x cubed. I add a power, divide by it. So what do we get? X to the fourth over 4, or 1/4 x to the fourth. So that's where my antiderivative goes. And I notate 1 to 3. So then we substitute in 3. So what is my 3 to the fourth power? 81. So now I have 81 over 4. Minus, when I substitute in 1, I end up with 1/4. And then we just do a little bit of math, and we end up with 20. All right. Now, when we started taking indefinite integrals, when we didn't have numbers involved on these integrals, we always added a what? We always added a c. However, you don't need to actually put a c now, because we're going to have it added over here, and then what? Subtracted over there. And so we don't actually need to add a c when we do a definite integral. So let's put it into practice. So now I have the integral from 1 to 2 of x squared minus 3 dx. And so all those practice with antiderivatives is going to help out here. And we'll see who practiced and who didn't real quick. So what is the antiderivative of x squared? 1/3 x cubed, or x cubed over 3. Either way is fine with me. And then what is the antiderivative of negative 3? Negative 3x. So that's my antiderivative, and I show it by putting a bracket from 1 to 2. And I always like to put that little parenthesis there. I don't know why, it just makes me feel good. All right, so now we substitute in our upper limit into the antiderivative. So what is 2 cubed? 8. So now I have 8/3 minus, when I substitute in 2, what do I get? 6. And so that's big F of B. That's what it is. And then minus, now I need to substitute in my lower limit. So when I substitute in my lower limit, I substitute in 1. So 1 cubed is 1. So now I have 1/3 minus 3. What would I highly suggest you do here? Distribute the negative. All right. I got paid a lot of money when I was in college to tutor a lot of people in calculus. And guess what most of their problems were? Distributing the negatives. All right. So don't pay somebody lots of money to say, distribute your negative. It got me lots of food, though, so that's good. I was fed. All right, so now 8/3 minus 1/3 is what? 7/3. So I'm going to deal with that guy first because they already have common denominators. And then -6 and 3 go to what? -3. All right. So now how should I think of 3? 9/3. So we have 7/3 minus 9/3, which is -2/3. All right. So what that means is I had more of my area underneath the x-axis. And so let's think about it. I kind of want to just talk about this one a little bit. What is x squared minus 3? It's a quadratic, right? And what was that quadratic doing? It shifted how much? Shifted down 3, right? And so my quadratic is kind of like that. And so what's happening is I have more area underneath my curve than it is above. All right, that's what's actually happening graphically. All right, so let's look at B. So now I have the integral from 1 to 4 of 3 square root x. All right, so first thing we need to do is find an antiderivative. So x is now to a power of what? 3 halves. When I antiderive, it's now to a power of 3 halves. But then what do I multiply by? 2/3. So now I have 2 times x to the 3 halves. And then it's going from 1 to 4. All right, pretty good on our antiderivative. Now all I do is substitute in 2 or 4 now. So when I substitute in 4, I would work with the lower index of your degree first. So 4 square rooted is 2. 2 cubed is 8. So now I have 8 times 2, which is 16. All right. And then minus, now I substitute in 1. So 1 to the 3 halves is 1. 1 times 2 is 2. So I end up with 14. All right. Now I'd like you to get your calculators out. I want to show you some cool things. Now that we know how to use our calculators, let's do part C. So we have the integral from 0 to pi over 4 of secant squared. So this is kind of on the note card. What is my antiderivative of secant squared? Tangent. So my antiderivative is tangent. And I'm going to be going from 0 to pi over 4. All right. And so now I substitute in pi over 4. Man, that unit circle is going to come back. So what is the tangent of pi over 4? 1. And then minus, what is the tangent of 0? 0. So we end up with 1 unit. All right, so it's just a 1 unit answer. Let's keep going. So now I have this integral. So I have the integral from 0 to 2 of absolute value 2x minus 1. Remember when we did derivatives with absolute values, I actually didn't really do the calculus style. I really don't think it's necessary here either. If we understand what absolute values do, we don't need to go calculus method. It takes too long, honestly. All right, so let's talk about this absolute value first. What are my slopes? I know this isn't the question here, but I want to talk about it for kind of last chapter. What are my slopes on in this graph? -2 and 2. All right, the flying V, -2 and 2, right? And so my V is going to be opening up. And where's my problem area at? We're going to do this graphically, just like we did the other one. It messes up at 1/2, exactly. And so I have this flying V that does that. And I want to find my area from 0 to 2, right? And so what I need to do is I need to find the area of this triangle, and this is not drawn to scale, and I need to find the area of that triangle. And how do you find the area of triangles? 1/2 base times height, right? So we need to find bases and we need to find heights. So let's find bases first. So what's the base right here? 1/2, all right? What is the base right here? What? 1.5, also known as 3/2. All right. Now I need to find the height of them. And so sometimes, yes, you can use your slope, but really it's easier than that. If this is 0, just substitute in 0 into this function. Just substitute in 0 into 2x minus 1 absolute value. So if I substitute in 0, what do I get?
1.
I get 1. So this height over here is 1. And then if I substitute in 2 to find my other height, what would my other height be? 3. All right. And so now I need to find the area of both of those triangles. So how do you find the area of a triangle again? 1/2 base times height. So I have 1/2. What's my base of my little triangle? 1/2 times my height of 1. Plus, I'm going to add up the other triangle. So I have 1/2 times, what's my base? 3/2, and then times 3. All right. See how we broke those two down? All right. All right, so now we have to do a little bit of math. 1/2 times 1/2 times 1 is 1/4. Plus 1/2 times 3/2 times 3 is 9/4. So what do we get? 10/4. Good, buddy. All right. So my integral is 10/4. All right, pretty good. I could reduce that or simplify it to 5/2, but ain't nobody got time for that. All right, let's do one. Let's do another one. All right, Chulin's going to read this one. Wake her up.
Find the area of the region bounded by the graph of y equals 2x squared minus 3x plus 2, the x-axis, and the vertical lines x equals 0 and x equals 2.
All right, fantastic. So if I need to find the area bounded by something, what do I need? It says area under curve. What is it? That's an integral. So we're going to take an integral. And what are my limits on this integral? 0 to 2. That's how it's read. And so my function ends up being what? 2x squared minus 3x plus 2 dx. All right. So an integral is an antiderivative, area under the curve. So we need to take an antiderivative of that. So what is my antiderivative of 2x squared? There we go. What is the antiderivative of 2x squared? 2/3 x cubed. All right. And then what is my antiderivative of negative 3x? Negative 3/2 x squared. And then what's my antiderivative of 2? 2x. All right. And it's going from 0 to 2. And so we substitute in 2. So we got to do a little bit of math. And what I found out is some people lack algebra skills. So let's do it. So 2 cubed is 8. 8 times 2 is 16. So I have 16/3 minus. Now I substitute in 2. So 2 squared is 4. 4 divided by 2 is 2. 2 times 3 is 6. So we have negative 6. And then 2 times 2 is 4. And then minus, when I substitute in 0, what happens? It all goes to 0. Isn't that nice? That was nice. All right. And so now I end up having 16/3 minus how much? 2. So how should I think of this negative 2? Negative 6/3. All right. And so what do I end up having? 10/3. So my answer would be 10/3. All right. Pretty good? All right. Let's keep going. All right. You will have something like this on the AP exam. You're going to be so happy when you see problems like this. So I have the integral from 0 to 5 of f of x equals 10. And the integral, you should probably write these out. And then the integral from 5 to 7 of f of x is equal to 3. And so that means the area from the curve from 0 to 5 is 10. And the area from the curve of 5 to 7 is 3. And we're going to evaluate these other ones. All right, and so I need to go over the concepts of how to do it. They're pretty easy. So if I have to do the actual integral from 0 to 7, this is called an accumulation. Well, what would it be?
13.
13. How did we get 13?
10 plus 3.
10 plus 3. Exactly. So if it's from 0 to 5 is 10, and from 5 to 7 is 3, from 0 to 7 it would be 13. Pretty easy? All right, let's show you this next one. So on part B, it says the integral from 5 to 0 of my function. Now, I don't know the integral from 5 to 0 because it didn't tell me yet, right? But I do know what 0 to 5 is 10. So which way did it go now? Now it goes from 5 to 0, so it's going backwards. It's negative 10. Exactly. Exactly. So if we ever flip our integrand, okay, if we ever flip our limits, it's negative. All right? So if we have the integral from a to b of a function equals a number, c, then if I flip my limit, it would equal negative c. Oh, that's still equals c because I flipped my limit. All right. So if you flip them, you make it negative. All right. Let's look at part C now. Part C is the integral from what? 5 to 5. Do I have any width going on? No. So what is it? It's 0. I don't have anything. All right. All right, this next one, I have the integral from 0 to 5 of 3 times my function. So what would it be? 30. All right, my integral from 0 to 5 is 10. If I multiply by 3, I end up getting 30. All right, pretty easy? All right, there you go. I'd like you to work on that first. That was number 41 on 279, so you have to do 42 and 43. Not number 25. All right. So numbers 5 through 43 odd. Sorry, I forgot to take that off. All right.